Hi friends, welcome to Unit 5 Day 5 Notes. This is the last part, our two examples. The first one's talking about sketching triangles and then just use the information to determine whether they're similar. We're going to see that this one is actually one using side-side-side similarity and side-angle-side. We'll just see if they're similar or not. So for this first one, it says the side lengths of triangle ABC are 8, 10, 14, and the side lengths of triangle DEF are 16, 20, and 26. So for this one, I'm just going to make a quick sketch. So there's A, B, C, and then D, E, and F, assuming we're going to go 8, 10, 14, not drawn to any scale, and 16, 20, and 26. Okay, so now to check to see if they are, I'm going to do proportion of AB, adjust my camera here, of AB over DE is equal to BC over EF is equal to CA over DF. So AB is 8 over DE 16, saying if that's equal to BC, which is 10 over 20, saying if that's equal to 14 over 26. So 8 over 16 does reduce to 1 over 2. That's good so far. 10 over 20 also reduces to 1 over 2, so that's good. 14 over 26, ooh, that does not reduce to 1 over 2. That reduces to 7 over 13. Close, but not quite. So this one's not similar. So these two triangles are not similar. No triangle ABC is not similar to triangle DEF. So that's for that side. Now let's do the other one. So this one actually is going to use side angle side. So we're going to see if this one's similar using side angle side. So again, I need to sketch. So A, B, C, and then D, E, F. Looks like we've got the measure of angle B is 38 degrees. And then E is also 38 degrees, so I went ahead and drew the congruency arcs to show that those are congruent. AB is 15, BC is 24, D is 5, EF is 8. All right, so let's check to see if these are proportional. So that's going to be AB over DE, seeing if that one is proportional to BC over EF. AB is 15, over DE is 5, and then BC is 24, EF is 8. So that's 3 over 1, and also 3 over 1. So these are proportional, so yes, triangle ABC is similar to triangle DEF, and I need to say by the side angle side similarity. Helps if my handwriting is legible. Side angle side similarity. There we go. So we know that that is true. And then for this last one, in order to estimate the height of a pine tree, we place a mirror on the ground and stand where we can see the top of the tree as shown. We know that the student is 6 feet tall and stands 3 feet from the mirror, which is 11 feet from the base of the tree. So what we're trying to do here is we're trying to see if this is viable. So what we're doing is we're actually setting it up so that this is a side angle side similarity. So the angle that we get is actually the right angle that's made here and here. So what we can do is we can set up a proportion. So we know that 6 over, I'm going a different way, that's okay. 6 over h, so the 6 feet, so it's the heights. So 6 over h is equal to 3 over 11. And so this is all in feet. It's important to remember that we're keeping the units the same. So if I cross multiply, take 6 times 11 equals 3 times h. 6 times 11 is 66. 3h divided by 3. And so we get the height of the tree is 22 feet. So the height is 22 feet. Another student also wants to see the top of the tree. The other student is 5.5 feet tall. If the mirror is to remain 3 feet from the student's feet, how far from the base of the tree should the mirror be placed? So now we have another, now that we know the height of the tree, we're actually trying to find this amount. So we have the student being 5.5 feet tall, so 5.5 is going to go here. We have that right angle again here. We know that this is going to stay as 3. So then what we need to do now, we know that the height of the tree doesn't change. That's still 22. We just need to know where to place the mirror at. So this is our unknown distance. So I'm going to call this, let's call this x. So I don't know how far that needs to be. So we're going to still set it up exactly the same way that we did in the other one. We're going to have a different value here for this, though. It's not going to be 11 because we're going to see that the proportion still, for it to be true, we have to change it a bit. So for this, I'm going to do 5.5 over 22. So the heights, and then equaling the distance away from the mirror. Remember, the mirror is there. So 3 over x. Cross multiply just like we did earlier. So that's going to be 5.5 times x is equal to 3 times 22. So that's going to be 5.5x. When you multiply 3 times 22 is 66. So when we divide by 5.5, we get that the distance from the tree needs to be 17 feet. No, 12 feet, excuse me. 12 feet. So we need to be 12 feet away. So we need to put the mirror needs to be 12 feet away. And there we go. That ends the notes. I hope you have an amazing day. Bye, friends.